In this program, we're going to look at the basics of installing, maintaining and servicing domestic gas cookers, gas space heating appliances and water heaters. But before we start, there's an important general point to be made about every type of appliance. They're all covered by British standards regulations. There are various BS numbers and parts specific to particular types of appliance and the places in which they can be installed. We won't keep on quoting the different numbers at you because in this sort of presentation they might be confusing. But it's important to note right from the outset that they're crucial to the work you'll be doing. You'll find them in the manual, so always refer both to them and to the manufacturer's instructions at every stage of the job. First then, let's look at cookers. There are various different types and different arrangements of the basic elements. But whatever type it is, its parts are basically the same. There's the grill, which consists of a gas inlet, a burner, a grill fret, and an outlet for the products of combustion. Burner flames in grills are not all the same size. They're varied deliberately by the manufacturers to give a more even distribution of heat across the grill fret. That's the thin metal mesh which absorbs heat from the flame and radiates it downwards onto the food. The hot plate consists of burners, taps, and a spillage tray. In the hot plate, ports and retention ports stabilize the main burner flames, and there's a burner cap with an ignition electrode under it, and a burner mixing tube. The oven has its own burners, of course. If there's no fan, the temperature difference between the top and bottom shelf positions may be 25 degrees Celsius. That's equivalent to 2 gas marks. A fan gives a more even distribution of heat. The flame safety device lights the burner in 2 stages. First, a small gas flow heats the file. This vaporizes the liquid in the capillary. It expands and so opens the main valve. The small flame then ignites the main gas flow. The flame safety device makes sure that the main gas can't flow unless there's a flame to ignite it. The oven thermostat works in the same way. Its valve is spring-loaded and it's operated by a lever which pivots on a fulcrum point. As the oven heats up, this makes the bellows move. Turning the range setting knob alters the position of the fulcrum so that a range of temperature settings can be achieved. Many burners nowadays work on automatic ignition. This relies on electricity, either from a battery or the main supply. When the ignition switch is turned on, current flows to the ignition unit and from there onto electrodes in the oven, grill and hot plate burners. The ignition unit's commonly known as a spark generator. It takes low voltage electricity and raises it to between 10,000 and 15,000 volts. It travels to the electrode, jumps the gap, and so lights the gas. There's no need for a spark once the gas is lit, of course, so different techniques are used to stop it. The most common is that the electric current continues to flow through the flame, but without creating a spark. The flow's still there, but there's no noise. Automatic cooking can be achieved in various ways. Typically, though, it works like this. When the oven control's turned on, gas flows to a valve assembly in the clock and to the oven's flame safety device, while electricity flows to a micro switch in the clock timer. When cooking time starts, the gas flows through the valve assembly to stage 1 of the oven burner assembly, and electricity flows through the clock timer to the ignition unit. This creates a spark to light stage 1 of the burner. When the flame safety device file has heated up, about 30 to 45 seconds later, gas flows to the main burner and it's lit by the stage 1 flame. As the food cooks, the oven heats regulated by the thermostat as usual. When it's time for cooking to stop, a valve in the clock closes to stop the gas flow, and the microswitch in the clock timer opens so that there's no current flowing to the ignition unit and therefore no spark. Before installing a cooker, check the relevant BS regulations and, of course, the manufacturer's instructions. You'll find details of where you can and can't install it. Cookers are not allowed in bathrooms, shower rooms, or bed sits smaller than 20 cubic meters. They shouldn't be installed where they might be affected by excessive drafts or where they may cause an obstruction. BS regulations give very clear guidelines on points like clearance, the condition and strength of floors and work surfaces, and the presence of combustible materials. They also cover ventilation needs for rooms of varying sizes and characteristics. The types of connections used, gas and electric, are important both for natural gas and liquefied petroleum gas, LPG. Once again, the BS regulations are detailed and you must consult them every time. When you're sure that the location's right and that all requirements have been met, you can install the cooker. The flexible connector mustn't be positioned where it'll have any undue forces or excessive heat applied to it, or where it might be damaged. It has to be connected to a gas socket which is firmly fixed to the gas installation pipe and placed so that it hangs freely downwards, and make sure that the connector can be disconnected easily if necessary. Every appliance must be stable. You can use brackets for this, fixing them either to the wall or to the floor. If there's a stability chain too, make sure that it's as short as possible. When the installation's complete, the whole thing must be checked systematically. First check the installation for soundness. Then make sure that it works as it's supposed to. Next, check pressure, gas rate, and, where necessary, ventilation. Make sure that all the safety devices and controls are working. Check the seal on the oven door, and make sure the cooker's level. And finally, tell the customer how it all works and give him or her the manufacturer's instructions. Appliances should be serviced at least once a year. The best way of making sure you do a proper service is to follow the manufacturer's instructions. But if they're not available, here's a general sequence to follow. First, clear the work area and put down dust sheets. Before you do anything else, test the gas installation for soundness. Examine the appliance thoroughly and ask the customer how it's been performing. Now we need to check the electric wiring for damage and make sure that all connections are secure. If it's mains fed, make sure first of all that it's disconnected. Then check that the supply's earthed, correctly connected, and that it has a 3-amp fuse. If that's all okay, check that the flexible tubing's sound and that the plug-in connector is working. And if there are stabilizing brackets and/or a chain, check them too. Finally, before moving to individual components on the cooker, check that it's level and that if there's a movable base fitted, it works. Now you can start on the cooker itself. First, check all the taps, and after disconnecting them from the gas supply, ease and grease them if they need it. Once the appliance has been reconnected to the gas supply, make sure that the appliance pressure's correct, and if a governor's fitted, for example, as in an LPG appliance, check that it's clean and level. Now look at the whole ignition system. Check that all the ignition devices and electrodes are clean, and that the ceramics and insulation are in good order. Test the ignition to make sure it's satisfactory. Then finally, if there's a battery, check its condition. You can now move to the burners. Clean them, the main ports, retention, and the cross-lighting ports. Look at the flame picture on all of the burners. Clear the injectors if required, and if it's necessary, but always on LPG appliances, adjust the aeration. Next come the various safety devices and control systems. The file on the flame safety device should be clean and in the right place. The heater flames must also be correctly aligned. Make sure that the thermostat's working properly and that the bypass rate is as it should be. The thermostat file or rod must be positioned correctly. Next, see that the door seal and catch are working and that the flueways are clear. And finally, when you've tested for soundness and checked the various automatic cooking devices, electric lights, switches, motors and solenoids, whichever are fitted, the job's finished and you can clear up the area and wipe the cooker. Some of the faults that can occur are caused by spillages and other everyday results of cooking. They can cause blockages which may lead to ignition problems, poor combustion, unstable flames and smells. The cure is to give the cooker a good clean. If the customer is finding that food is being cooked unevenly in the oven, there are several possible causes. The cooker may not be level, the linings could be misplaced or the shelves distorted. If it's not any of these things, do a systematic check on the cooker's features, flame picture, gas pressure, ventilation, and so on. Check each element and process systematically. Flame safety device, thermostat, flue, door seal, and timer. And make sure the appliance has been properly assembled. And last but not least, is the customer actually using the right cooking method? As we've already said, appliances fueled by liquefied petroleum gas need different fittings and have their own distinct BS regulations. Special taper plug valves, valve lubricants and flexible connectors are needed for liquefied petroleum gas. Appliances which use this type of fuel can't be installed in cellars or basements, and if they're installed in a caravan or some other non-permanent dwelling, there are special ventilation requirements. As we indicated right at the start, all appliances and installations must conform with BS regulations and manufacturer's instructions. If you're ever in doubt, or even if you're not, always check them. We said that there were lots of different cookers. The same is true of space heaters. They're simple, easy to control, and economical. It's also easy to work out exactly what rating of heater to use for a particular room. You measure and calculate the room's volume and divide it by 10. So a room of 30 cubic meters would need a 3 kilowatt heater. As with cookers, the basic components of the various gas fires are the same. There's the firebox, an aluminized steel container for the items that make up the fire itself. These are, first of all, the radiants which radiate the heat. They're fragile and can reach temperatures of 1000 degrees Celsius. The thorns on them create a greater surface area, distribute the heat from the burning gases, and give an even luminous appearance. The fire brick refracts heat from the radiants away from the internal parts of the fire, and so stops the box overheating. The burner can either be simplex, in which all flames come from a single injector, or duplex, which allows various permutations. There are different injectors, and the burner itself is divided into sections to give a greater choice of settings for heat output. The fire guard is fixed to stop combustible material coming in contact with the radiants. There are several methods of installation, depending on the fireplace available. In each one, though, the fire has to have a closure plate behind it, sealed all round except for a relief opening. There must be a spigot to allow products of combustion to escape into the flue. However, remember to consult the manufacturer's instructions to see if and when a spigot restrictor is required. Below the spigot, there has to be a void big enough for that type of installation. The exact figures for these voids are listed in your written module. This applies whether you're dealing with a chimney with a solid fuel hearth already there, a proprietary fire surround, a precast block chimney on a hearth, a flue box with a pipe, or using a flue liner in a chimney, a fan draft flue system, or an existing chimney breast with a wall on which the fire's mounted. With this last example, an added requirement is that the fire's flame and all its incandescent materials have got to be at least 225 millimeters above the floor covering. Remember too that nowadays, if there's an open flued gas appliance of less than 14 kilowatts installed in an area which can be classified as sleeping accommodation, it has to be fitted with an atmosphere sensing device. As we said about cookers, whenever you're installing any appliance, always consult the manufacturer's instructions and the relevant BS regulations. Let's start with the location. Gas fires can't be installed in any room or internal space where there's a bath or a shower. They must be on the hearth or the floor, or else fixed to the wall. If there's a hearth, it must be made of non-combustible material, at least 12 millimeters thick, and extend at least 300 millimeters out from the fire and 150 millimeters on each side of it. And if the chimney has been used previously for an appliance burning some other type of fuel, it has to be swept. If a gas fire is fitted into a precast flue, it could create temperatures higher than 66 degrees Celsius on the flue wall, so you'll have to fit a cooler plate. But before you do, check that the appliance is actually compatible with that type of flue. Not all of them are. The flue pull should be tested at this stage. The tape or material used to seal around the edges of the closure plate must be able to withstand temperatures up to 100 degrees Celsius. It also has to be flexible enough to effectively seal uneven surfaces like stone. The size, type and location of flue spigots are critical. The manufacturer's instructions will give full details, so check them thoroughly before installation. The space below the spigot in the fireplace recess is called the catchment. On the closure plate, there are two openings, a flue spigot and an air relief opening. Gases exit through the flue. Any other gaps, cracks or openings in the fireplace recess must be filled. If there are any dampers fitted in the chimney, take them out. Always make sure that the fire surround is compatible with the particular appliance you're installing. Any materials near the spigot must be non-combustible, and the unit must be effectively sealed and secured to the wall so that air can't get in. With sidewall connections, there must be a gap of at least 500 millimeters between the flame or incandescent radiant source and the sidewall. Again, check the manufacturer's instructions. When you're satisfied with the installation, check for soundness and spillage. Check the burner pressure and make sure the appliance works properly. Before doing any sort of servicing, you must always remember to do the pre-checks you learnt in your service and maintenance modules. They'll involve pressures, ventilation, flue operation, and so on. For the service itself, the manufacturer's instructions are your best guide, but here's a general checklist you can work from. When you take the closure plate away, remove all the old sealant and any debris from the recess and check the condition of the chimney. Then, when you're ready, refit the plate and seal it with new material. Then check the flue pull. When you've taken off the case, you can remove the radiance. Next, clean all the dirt and lint from the grills and burner. There may be one or more injectors. Check and clean them. Make sure that the heat exchanger is not corroded and that the flueways are clear. Grease the control tap if it needs it. Then reconnect the fire and test the gas installation for soundness. The next check is on the ignition system and, if there is one, the flame safety device. Clean the radiants, put them back, then check the burner pressure. If everything's okay, you can now put the case back on, test the fire for spillage, and clear up the work area. These guidelines apply to all types of heaters. If you're installing a convector heater, there's one difference. You've got to make sure that no part of the combustible sidewall is less than 150 millimeters from the warm air outlet. Again, though, check the manufacturer's instructions. They may vary depending on the type of heater. If the appliance is fueled by liquefied petroleum gas, the same rules apply that we quoted in connection with cookers. i.e., it'll need special valves and connections, and it has different installation and ventilation requirements. These are known as insert live fuel effect, ILFE, and decorative fuel effect, DFE, appliances. The ILFE is in a heat exchanger box to convect heat into the room. The burner can be simplex, duplex, or of the sand tray type. Most of the rules about the siting of ILFEs are exactly the same as those which applied to radiant and convector fires. The rules for fire surrounds and the fireplace recess are the same too, but there's an additional requirement here. With ILFEs, the top surface of the hearth has to be at least 50 millimeters above floor level. An upstanding edge, like a fender along the front and sides, would do as long as it's 50 millimeters high. The idea is to discourage folk from putting carpets or rugs on top of the hearth. Wall-mounted ILFEs don't need a hearth if the flame or incandescent material is at least 300 millimeters above the floor. Some manufacturers, though, may ask for a hearth to be fitted in case hot coals fall out of the fire. Don't ever fit combustible material inside the fire recess. And, as we keep on saying, always check the manufacturer's specific instructions. With precast flue block chimneys, this is crucial because some manufacturers advise against fitting their products in such locations. And, of course, it's common sense to tell the customer to use a fire guard, especially if they're going to be children, elderly, or infirm people near it. Make sure that the guard they use conforms to BS regulations. The final appliance in the program is the DFE, Decorative Fuel Effect Fire. You can see from its open construction that a Class 1 flue is required. The rules about siting, hearths, catchments and so on are all exactly the same as those for ILFEs. The only additional point is that the fireplace recess must have a smooth gather to help the flue system to work effectively. DFE fires are only about 20 to 25% efficient, so to get good heat out, the input has to be high. That means they need additional permanent ventilation, usually a minimum of 100 square centimeters of effective area. And that's true even if the heat input is below 7 kilowatts. So again, always consult the manufacturer's instructions. Servicing of ILFEs and DFEs is the same systematic procedure we've already described. Start by clearing the work area and laying down dust sheets. Test the gas installation for soundness, isolate the appliance from the gas supply, then disconnect it and remove the fire. Before you start on the fire, check the flue system and remove any debris, then check the flue pull. Now remove the coals and the sandbed or burner assembly from the fire. For the sandbed type of fire, check the tray and the distribution pipe for faults, and if there's an injector, inspect it and clean it. Refit the coals and sandbed. Check the control tap and grease it if it needs it. And now you can put the fire back together, reconnect it to the supply and test again for soundness. If that's okay, check the ignition system and the flame safety device and see that the burner pressure is correct. When you've tested for soundness and the flue for spillage, you can clear up the work area and the job's done. The two faults that occur most frequently with the sandbed types of DFE and ILFE are that the flames are either too low or too high. If they're too low, the sandbed may be too compact. Just relay it. Flames which are too high may mean that there's not enough sand in the bed. The final section of this program deals with domestic hot water heaters. There are basically two different types, instantaneous and storage. The heat input into an instantaneous single-point water heater like this one should never exceed 12 kilowatts, so they're usually flueless, not always though. They'll need a flue if they're serving more than one outlet, the outlet's in another room, they're likely to be used for more than 5 minutes at a time, the volume of the room they're in is less than 5 cubic meters, or if it's a bedsit, less than 20 cubic meters. And if the heater's in a room which has a shower or a bath in it, the flue system must be room-sealed only. So how does it work? Well, when there's no water flowing, the pressure on each side of this rubber diaphragm is equal. When the tap's turned on, water flows through the venturi, and as the flow increases, pressure at the throat of the venturi is reduced. As a result of that, the pressure above the diaphragm is reduced, and it's pushed upwards. It moves the bearing plate, which in turn lifts the gas valve, and the gas can flow. If the pilot's lit and the flame safety device is open, gas flows to the burner, gets lit by the pilot, and heats the water. The flame heat is transferred to the water via the finned heat exchanger, and the appliance's design makes sure that the water flow rate is constant so that the heat is transferred efficiently. Installation is relatively simple. The appliance is connected to the mains water supply next to a sink with its spout over the bowl. As with all other appliances, always check the manufacturer's instructions and the BS regulations. This is a large instantaneous hot water heater. It delivers hot water to draw-off points throughout the property, so it's commonly known as a multi-point water heater. Heat input is usually greater than 12 kilowatts, so it needs to be flued. Normally, it's room-sealed. The temperature of the outlet is controlled by a vapor pressure thermostat, and there's a cylindrical throttle which restricts the water flow in the heater. As the bellows move, they reduce the flow, and with less water to heat, its temperature rises, and so the outlet water is hotter. If the water flow dropped too much, the heat exchanger might overheat. So, to prevent that, the throttle assembly is connected to the automatic valve of the water section through this small pipe. This means that it acts as a venturi. If the flow rate through the heater gets too low, the differential pressure in the heater's automatic valve section will equalize, and the gas flow to the burner will be shut off. This is a simpler method. It's a temperature selector which is simply a screw in the throttle which alters the water flow rate and so changes the water temperature. Water pressure in the mains can vary just as gas can, so to counteract that, a water governor is fitted. It works in the same way as a gas constant pressure governor. Another controlling feature is the slow ignition device. It regulates the gas flow to the burner to cut down ignition noise. This adjusting screw in the low-pressure duct connects to the venturi. When the valve's opening, the loose ball blocks the central orifice. That reduces the flow from above the valve's diaphragm and graduates the opening of the gas valve. When the valve's closing, the loose ball moves out of the orifice. The flow to the upper side of the diaphragm increases and the gas valve closes quickly. Thanks to this constant volume governor, the volume of the gas delivered to the burner doesn't vary. That means that instantaneous water heaters only need to increase or decrease the flow of water to control its temperature. The greater the flow, the lower the temperature, and vice versa. Basically, the governor's an aluminium disc float which slides over a vertical tube. The various gas ports in the tube are closed or opened depending on where the float is. As the supply pressure increases, so does the flow, and consequently the pressure differential across the float. That makes the float rise, closing ports as it moves, and so reducing the flow again. The flame safety device is a bimetallic strip. When it's heated by the pilot light, it bends and opens the main gas valve. If the pilot or gas goes out, the strip returns to its natural shape and closes the valve. Today, it's being replaced by a thermoelectric valve. When dissimilar metals are heated by a pilot light, they produce an electrical current, which creates an electromagnetic effect. This holds the main gas valve open. A multi-point installation can either be connected directly to the water mains or to a feed system. A service valve should be fitted to the heater's cold water inlet so that the appliance can be isolated for maintenance. And if the water mains pressure is greater than that recommended by the manufacturer's instructions, it may also need a pressure-reducing valve. You'll need to check the manufacturer's notes as well if you're using a feed system, because the head of water is important. Remember too, always check the BS regulations. If hot water draw-off pipes are too long, they're obviously going to lose a lot of heat. Keep them as short as possible. For pipes up to 22 millimeters in diameter, the maximum length is 12 meters. Between 22 and 28 millimeters, it's 7.5 meters. And over 28 millimeters, the maximum is 3 meters. You can usually install a washing machine to the hot draw-off, and showers too are okay. But with showers, there are a couple of things to remember. First, the hot and cold water supplies to it should come from the same source, i.e. both from the feed system or both from the mains. Next, the head of water has to comply with the manufacturer's instructions. And finally, you must only install the shower type the manufacturer recommends. One last general point. These larger instantaneous installations obviously need a lot of gas. Once again, the manufacturer's instructions will give you the necessary details, but always be aware of the need for a significant gas supply, and always make sure you've complied with local water bylaws, gas safety and building regulations, and the relevant parts of BS. Before you start on the actual commissioning of an instantaneous heater, you should first check that it's suitable for the location, that it's sound, and that there's adequate fluing and ventilation. Manufacturers spell out how to commission their appliances, but there's a basic general procedure you can use for both small and larger appliances. First, make sure the gas is off. Then turn on all the hot taps or the appliance outlet. Now turn on the water service cock, and when the water's flowing freely, turn off the taps or the appliance outlet.
Turn the gas on.
Check for water leaks, and if there are none, turn on the gas and light the pilot. Make sure the ignition device is working, and that the pilot flame's okay and set properly in order to heat the flame failure device. With the appliance set to main flame, turn on the hot tap. The burner should ignite. Now you look at the burner. Check that the pressure's right, the connections are good, and use leak detection fluid to make sure that there's no gas escaping. When you've checked the flame picture and made sure that the water's flowing and heating up as it should, turn off the hot tap again. Then when you've turned off the pilot and checked the flame safety device, you should tell the customer how the heater works and remind them that the appliance needs servicing once a year. The servicing procedure is just as logical. When you've looked over the installation to see that it complies with all the relevant regulations, check it to make sure that it works. Then turn off the gas and water valves and take off the outer case. Drain off the water, either from the taps or the drain plug. When the appliance is empty, take out the burner and heat exchanger and clean the flueways. Clean the burner thoroughly. Do the same with the pilot burner. Check the ignition and flame safety devices and clean all injectors. If there are gas and water filters fitted, check them, and if necessary, grease the control valve push rods. When you're sure everything's clean and working properly, reassemble it all, renewing all the jointing washers as you do. Test the gas installation for soundness and make sure that there are no water leaks at the heat exchanger connections. Next, test the ignition device and the flame safety device. Then check the burner pressure. Finally, when you've made sure the heater's working and checked the seals, you can put the case back on, and that's it. The sort of faults you get with water heaters are fairly predictable and usually easy to trace. You'll find a list of them, together with possible causes, in your written module. A hot water circulator heats storage hot water using gravity flow and return pipes. The water in the storage cylinder can either be heated by a direct or an indirect system, and by one of two types of circulator unit, a back boiler or an independent one. They have similar components, and installation is basically the same, but their locations are very different. Independent units can be installed in a warm air unit compartment or in a cupboard next to the water cylinder. They may be fitted with a multifunctional control unit like this. It houses the appliance's control systems, the gas governor, flame safety device, and thermostat control assembly. The back boiler is fitted into a fireplace, so before you install it, you have to check the chimney. There must be no problems with downdrafts. It has to be swept and high enough to meet the manufacturer's requirements. It's important, too, that the flue is big enough to cope with the maximum combined ratings of a fire and back boiler unit. Finally, any pipework in the fireplace recess has to be wrapped with a protective coating to avoid corrosion. They can be connected to the storage tank either directly or indirectly. In the direct system, the water heated in the circulators is in direct contact with the hot water supply to the draw-offs. In other words, it's the same water. If there's a danger of scale being formed, an indirect system should be used instead. In an indirect system, the circulator water isn't the same. Instead, a coil fitted in the hot water cylinder transfers the heat to the stored water. When you're installing a circulator, as with all other appliances, make sure you comply with all the relevant regulations, and that includes making sure that there's a big enough head between the circulator and the hot water cylinder. Be careful how you use horizontal runs. Keep them minimal. Make sure they rise 25 millimeters every 3 meters, and wherever possible, use large radius bends. The manufacturer's instructions will tell you the maximum allowed pressure head. The flow connection to the cylinder has to be no more than 75 millimeters from its top, and the usual pipes are 22 or 28 millimeter. Heat input rates are usually around 4.4 kilowatts, so the gas supply pipes should be 15 millimeters in diameter. They can't be installed in bathrooms, bedrooms or bed sits, and if they're fitted in an airing cupboard, the cupboard must have low and high level vents with at least 90.3 square centimeters of effective area. When you're satisfied with the installation, the appliance has to be commissioned before it can be used. Servicing is a logical process. First, check that the appliance complies with regulations and make sure that it works. Then turn off the gas service valve. Check the gas control valve and grease it if necessary. Remove and clean the main burner and the pilot. Clean the injector and the heat exchanger flueways. Put it all back together and test the gas installation for soundness. Now check the ignition and flame safety devices and the pilot flame. If they're as they should be, move on to the burner. Test its pressure, the flame picture, and the gas rate. Finally, make sure the controls all work, that there's no spillage of flue products or water leaks, and switch it on to check that it's operating properly. And the final appliance for us to consider is this multi-point storage heater. It could be installed in place of a hot water cylinder. It's not an instantaneous water heater, but basically a storage cylinder with a gas burner and a heat exchanger below it. Usually, its flue passes up through the center of the storage cylinder. The typical heat input for one of these is between 6.5 and 8 kilowatts. So if it's an open flue type, ventilation is very important. As with everything else, the way to make sure you're doing the right thing is to check the manufacturer's instructions and the BS regulations. The controls, installation, commissioning, servicing, and even the typical faults of appliances like these are all very similar to those we've already looked at when dealing with circulators. And the regulations applying to water heaters which are fueled by liquefied petroleum gas are identical to those for cookers and space heaters. It's been a long haul, and there's plenty to remember. But basically, it follows the same pattern each time. Use a logical approach, and above all, never take chances with safety. Good luck.